Okay, here we are at objective 2. In this slide you can see there's pictures of orbits of stuff, and the orbits of celestial bodies traces out the path of an ellipse. So there's another application of an ellipse. So we're going to be able to write the equation of an ellipse in standard form. So in this video what we're going to do is we're going to do a bit of crazy algebra to come up with this equation first. Okay? And if you actually watch this video, it might give you some tips on how to earn yourself some points for the 6 weeks. Some bonus points. Extra credit. So let's start off with like a little warm-up. Here what I'm trying to do is I'm trying to solve this square root equation. And there's square roots on either side. So that's always a tip. Whenever you go to solve a square root equation, if you've got more than one, you want to separate them so they're on opposite sides of the equation. Okay, opposite sides of the equal sign. And then the way that we get rid of square roots is that we square both sides of this. Now, let me just remind you that whenever I square a binomial, it goes like this. Let's say it's a plus b squared. I square the first one, keep the same sign, so plus. Now multiply the a, the b together, and then double it. So 2ab. And then finally square the last one, b squared. So we're going to do that on both sides of this equation. I'm going to square this side, and I'm going to square the right side. Okay. So the tough one is squaring the left-hand side, because can you see how this is like my a term, the square root of x plus 2, and the 1 is like my b term. So it's really a binomial that's kind of complicated. So I'm going to square the square root of x plus 2. That's like my a squared. And the square root will cancel out, leaving me with just x plus 2. Okay, and now I need to multiply these two together and then double it. So I'll have plus 2 square root of x plus 2. And then finally I want to square that last number plus 1. On the right hand side, square and square root, they just cancel each other out, and I have 3 minus x. Okay, now watch what happened. I still have a square root in here, and I need to get rid of it. The only way I can get rid of it is by squaring both sides again. So we want to get that square root all by itself and get everything else on the other side of the equation. Okay, so let's see. Let's take the 2 plus the 1. That makes 3, so plus 3. And that will cancel out with the 3 that's on the other side. How convenient. And then finally, I'm going to take this x and I'm going to subtract it over to the other side, and that's going to leave negative 2 of them. So let's bring down the square root. 2 square root of x plus 1 x plus 2 is equal to, and what did I want to do? Subtract the x over, so I have negative 2 of them. Both sides of this have 2's. Let's divide by 2. Make it a little simpler. Square root of x plus 2 equals negative x. To get rid of this square root, I have to square both sides. Square it and square it. On the left-hand side, now the square root is going to disappear, and I'm left with x plus 2. And on the right-hand side, when I square negative x, I get x squared. It becomes positive. This is quadratic. Let's get everything onto the right side of the equation. This time, make it equal to 0. So x squared minus x minus 2. And I think that might be factorable. X and x has to be a 2 and a 1, and a negative 2 plus a 1. Which means that my answers are x is equal to 2 and negative 1. And it's at this point that you really want to put them back in the original equation and check for extraneous solutions. Because in the process of squaring both sides, I could have taken something that was negative and turned it positive, which would, sometimes screw up these square roots in here. But both of these happen to work. Okay, so I showed you this because that's what you're going to have to do in order to come up with the equation of an ellipse. So let's not go that way, let's go this way. Remember that the locus definition of the ellipse says this. It says that this distance, which I'll call d1, plus d2, when I add those two together, it's constant, and it's equal to the length of the major axis, which is 2a. So basically, in terms of the points that are on here, I have from P to F1 plus P to F2. This should be equal to 2a. Now notice that what I did on this is that I put the center point at the origin and then had 2a being the length of the major axis, 2b being the length of the minor axis. I did it like that just because that's going to be really, well, I'm not going to say easy, but it's going to be way easier to come up with the equation than if this thing was just at hk. So speaking of that, since that is so tough, I'm going to turn that into an extra credit assignment for 5 points in your 6 weeks average, if you can actually come up with that equation yourself. Okay, so in the meantime, let's do this slightly easier one. So, by the definition, what we just wrote on the other one, that P to F plus P to F2 has got to be equal to 2a. Now what we're going to do is just use the distance formula on P to F1 and P to F2. So, distance formula, difference between the x's, so from P to F1 it's x minus 0, that's going to be squared, and y minus c squared, and you take the square root of all that. So this is what it's going to look like. The first one is the one that's over there on the left hand side, and P to F2 is on the right hand side. So let's talk about the second one, from x minus 0, so that's in there squared, plus y minus a negative, which makes it plus c squared on this one. All of this is equal to 2a. So can you see how this is similar to the warm-up question? Because there's two square roots. And what we're going to have to do is we're going to have to separate those square roots, one on one side and one on the other one. Okay. So this is just going to go to the next slide because obviously there's not enough room to do it here. So I just copied that from the other slide. And in the first set of square roots and the second square root, I can simplify that just a little bit, and I can get rid of the minus 0 because that's just garbage. And then I took this square root and I just subtracted it to the other side, so that now they're separated. Now the tip is I have to square both sides. When I square the left hand side, that one's the easy one because the square and the square root is just going to exactly cancel out. The right hand side, that one's the one that's a little tricky. So obviously the square and the square root cancel out, so I'm just left with x squared plus y minus c squared. That's the same stuff that was underneath that square root symbol. Now on the right side I have to square the first term, so that's 4a squared, multiply them and then double it, so 2a times this negative square root thing, and then double it to make it 4a times that square root. And then finally you square the last term, so the square root and the square will cancel out again. Now is there anything I can get rid of? Well, certainly I can get rid of those x squareds. Now let's expand out these two binomials with the y and the c's in them. So I expand those things out, and now I can start canceling some more stuff. That's awesome. So the y squareds are going to cancel out this time, and the c squareds are going to cancel out. Okay, now I still have another square root that's in here. So I'm going to separate the square root and everything else. So what I've done is I'm going to go ahead and add the square root over to the left hand side so it keeps it positive, and I'm going to take this negative 2yc and I add it to the other 2yc that's on the right hand side. So this is the equation that I have so far. Alright, so now notice that everything has 4's in it. I'm going to just divide by 4, get rid of all the 4's, makes it a little simpler. Now what am I supposed to do? I have a square root. To get rid of the square root, I have to square both sides of this equation again. So when I square both sides, can't forget about this a squared, right? I square the a and I square the square root. So the square root and the square, they'll cancel out. And on the right hand side, a squared squared becomes a to the 4th. And let's see, what happened here? Plus 2e, oh, because it's a binomial, right? It's a binomial, I had to square that thing out. So the first one squared, and then multiply the two of them together and then double it, so 2a squared plus yc. And then finally the last one squared, so y squared c squared. Now, there's obviously not enough room and we're not done yet, so we're going to bring that to the next slide. Okay, so to simplify this a little bit, let's get rid of this a squared that's right out front. Let's divide both sides by a squared. And it simplifies everything except for that last term because it didn't have an a squared in it. But that's okay. Don't worry about it. We're going to fix that problem in just a minute. Now, we're going to expand out this binomial. Expand out one more binomial here, like so. Can we cancel anything out? Yeah, the two yc's from both sides, those are gone. Now I'm going to get the x squareds and the y squareds on one side of the equation and everything else on the other side of the equation. So that means that this fraction thing has to go to the left side and the c squared is going to go to the right side. So that'll look like this. Now with the y squareds I have a pair of them. I need to get a common denominator between those two terms so that I can simplify that term. So the common denominator obviously is going to be a squared. So if I multiply the top and the bottom by a of that term by a squared, I have a common denominator. Okay, so now I can factor out a y squared from these two terms, and across the top it's going to be y squared times a minus c, a squared minus c squared. Hey, wait a minute. Don't you remember this? This is from the last objective. And that was the anti-Pythagorean theorem that goes like this, that c squared is equal to a squared minus b squared. Well, if I add this to this side, and I subtract this from that side, I get that b squared is equal to a squared minus c squared. So on these two places where I have a squared minus c squared, I can take it out and put a b squared in its place, and it makes it a little simpler. One last step. One last step is that I'm going to divide both sides of this equation by b squared. When I divide both sides by b squared, then x squared will be divided by b squared. The b squared that's on the y squared term is going to cancel out, and b squared divided by b squared is 1 for the right hand side. So here is the simple form of this equation. This one has a vertical major axis, and the center point of this whole thing is at the origin. So if I wanted to, I could take this one and now shift it by h and k using SRT transformations. So that's how I can get the other, all of the other ellipses. If I just shift this by h, right, left, and k, up and down. And this is on your flow chart. Now, if you're interested, what you would have to do is prove the second one that's right here all by yourself. So instead of starting with 0, 0, you actually have to start with hk. So if you imagine all that algebra that we did on the previous couple of slides, it's going to be insane for this one. It'll definitely be worth 5 points on your average.